is in scientific notation if it is of the form a times 10 to the n, where a is between 1 and 10, and n is an integer, positive or negative, or even 0. Scientific notation is used in the sciences, hence why we call it scientific notation, to make reading really big and really small numbers easier. An example of a very large number would be the distance to the next galaxy. An example of a very small number would be the weight of a single atom. Let's begin by looking at converting from scientific notation to standard or decimal notation. Standard notation is what we would call our typical notation. There's no times 10 to the blah, blah, blah. So our procedure. First thing we want to do is if the exponent is larger than 1, we're going to move the decimal point in spaces to the right. So if 10 has a positive exponent, then it's larger than 10 by that factor. For instance, 10 squared is 100, 10 cubed is 1,000, 10 to the fourth is 10,000. When multiplying by a positive power of 10, we want to make the number larger, i.e. we're going to move the decimal point to the right. If the exponent is smaller than 0, then we want to move the decimal point in spaces to the left. If 10 has a negative exponent, then it is smaller than 10 by that factor. For instance, 10 to the 0 is 1, 10 to the negative 1 is 1 over 10, or 0.1, etc. When multiplying by a negative power 10, we want to make the numbers smaller, i.e., we're going to move the decimal point to the left. So let's look at a couple of examples. First one we have is 2.6 times 10 to the 7th. So, since we have an exponent of 7, that means that I want to move my decimal point 7 spaces to the right. So 1, 2, 3, 4, 5, 6, 7. In each one of our little cloud poofs, we're going to put in a 0. Now recall that our decimal point is on the right side now. And so now if we write this without all of our cloud poofs, we get 26 followed by 6 zeros, or, and this is a mistake on here, 26,000. Let's look at example B. We have 1.1 times 10 to the negative 4, which means that I want to move 4 spaces to the left. My decimal point is now 3 spaces in front of the 1.1, and again I want to fill in each empty space with a 0. And so we get 0.00011. Try the next two on your own. Let's now talk about converting from standard to scientific notation. The first thing that we want to do is we want to move the decimal point so that there is only one number in front of the decimal point. Remember that your number has to be between 1 and 10. From there, we want to count the number of times that we had to move the decimal point in order to get that number. If the original number is a large number, larger than 10, then your exponent is positive and it's equal to how many spaces you move the decimal. If your original number is smaller than 1, if it's a small number, the exponent is negative, and again, the number part of the exponent is equal to how many spaces you moved. So let's look at some examples. For example A, we have 4,600,000. My decimal point is right after the last zero. So the goal is to move the decimal point to between the 4 and the 6. That would give me one digit in front of the decimal point, and this would be between 1 and 10. So how many spaces do we have to move the decimal point? Well, to move the decimal point, we're going to go 1, 2, 3, 4, 5, 6. So we get 4.6 times 10 to the, since we moved it 6 spaces, we get to the 6th power. That takes care of example A. For example B, what do we have to do? Where are we aiming for? And so on this one, we are aiming between the 2 and the 3. We would have one digit in front of our decimal point. So how many spaces do we have to move in order to get there? 1, 2, 3, 4, 5 spaces. So we get 2.3 times 10, and again, since this was a small number to start with, we get an exponent of -5. Take a moment. Try the next two on your own and see what you come up with. Hopefully you got the same answers that I did. On D, I will let you know that I am trying to count without actually putting dots on my paper, and so this one might be off, but it should be negative, and the number of spaces that we had to move. I'm getting a little cross-eyed looking at all the zeros. Let's now look at computations with scientific notation. This is where we're going to bring in our rules of exponents. In order to perform computations with scientific notation, the first thing we want to do is multiply the operation on the numbers. Either multiply, divide, raise to the exponent. We're going to do that to our number portion, our a's. From there, we want to use rules of exponents to determine the exponent of 10. So for multiplying, we will add the exponents. If we're dividing, we will subtract the exponents. For raising to an exponent, we will multiply. The last thing we want to do is check that the number portion is between 1 and 10. If the number is larger than 10, then you need to move the decimal point to the left and add the number of moves to the exponents. You need to balance. If you make the number smaller, you need to make the exponent larger. Similarly, if the number is smaller than 1, you want to move the decimal point to the right and subtract the number of moves from the exponent. If you make the number larger, you have to make the exponent smaller. So let's look at some examples. Example A, we have 4 times 10 to the 5th plus times 2 times 10 to the 9th. So we multiply our numbers. 4 times 2 is 8. And then we want to add our exponents. Remember that we're multiplying here, so this is kind of, what do we do with exponents when we multiply? We add them. So we should get an exponent of 14. So our final answer is 8 times 10 to the 14. Since 8 is between 1 and 10, we are done. For example B, we have 1.2 times 10 to the 6th over 4.8 times 10 to the negative 3. We are dividing here, so I want to divide my numbers. 1.2 divided by 4.8 equals 0.25. We want to make sure that we write our answer as a decimal because scientific notation is all about decimals. Times 10 to the, we want to subtract our exponents. We get 6 minus negative 3. We change our minus negative 3 to a plus 3. And so we should get 0.25 times 10 raised to the 9th power. Now we want to check that the number is between 1 and 10. Since this number is not between 1 and 10, we do need to do something else. So we want to go ahead and move our decimal point to the right. So we're going to turn our 0.25 into a 2.5. Since we are making our number smaller, since we are making our number larger, I want to make my exponent smaller, so I'm going to subtract 1 from the 9. And so my final answer is going to be 2.5 times 10 to the 8th power. Let's look at one more example. We have 5 times 10 to the negative 4 raised to the 3rd power. So we are raising to an exponent. The first thing that I want to do is raise my 5 to the 3rd power. We're distributing our exponents. So 5 cubed equals 125. And then since we are raising to an exponent, we want to multiply our exponents, so we get times 10 to the negative 12. Is our number between 1 and 10? For this one, no, it's not. Since it's not, we want to move our exponent. We want to move our decimal point 2 places to the left and make it 1.25. Since we are making our number smaller, we want to make our exponent larger. So I'm going to add 2 onto my exponent, giving us a final answer of 1.25 times 10 to the negative 10. Remember that we have different signs, and when we add numbers with different signs, we want to subtract. Keep the sign of the larger number. Try the next ones on your own and see what you come up with.